Hi everyone, welcome back to Java 1 for All. Continuing the Java.time saga, we are going to talk now about the instant class. Let's create another class inside our package of dates, our dates. Right click, new Java class, instant test 01. So the instant class, it works similarly to the date class. The date class work with the milliseconds from January 1st, 1970, and the instant works in the same way from January 1st, 1970, but instead of milliseconds, it works with nanoseconds. Now, if we want to create an instant object, basically it's the same thing as you have been doing so far. You call instant.now. So what is instant? So instant, it represents, if you scroll all the way up for this huge documentation, an instantaneous point on the timeline. Now, the funny thing about the instant, since it's working with nanoseconds, it cannot hold, for example, any long variable cannot hold the full nanoseconds from 1970, January 1st, 1970, until this day. So they split it in two different variables, one for seconds and one for nanoseconds. But before I get there, let me show you basically how it works. So if we print here instant, and I'm going to print an instance and something from local date time, you will notice one tiny difference. So the first one is the instant object, and the second one is the local date time. The T is just a representation that we have to split the date and the time. And what is different from the instant and the local date time is that instant always returns the value in the Zulu time. If you search for Zulu time, is basically what the militaries they use to represent like a neutral point. Everybody in the whole world, if they search for the Zulu time, they will get exactly the same value. There is no time zone, it's like the 0. Zulu time is also known as UTC time. I think there is no difference. I'm not sure exactly what is the difference, but they have exactly the same time, UTC and Zulu time. So every time you see that Z, it means that you are working with a neutral time zone. Everybody in the whole world, if they check the time, they will see the same thing in UTC. And this is useful because when you are working with applications that needs to store data, actually data and date related, you have to be careful because, for example, let's say I store this data in the database and someone in Tokyo is getting this date back and they want to know, for example, when that happened in the Tokyo time. Now, I have no idea because, for example, if I just store this in the database, there is no indication saying, okay, this is the actually CET time zone. So the CET time zone is the time zone represented as Central European time. And this is what exactly my time is now. Now the problem is that, for example, if they want to fetch it there in Tokyo, if they don't know the time zone, they may not get an accurate time representing this. So the Zulu is useful because, for example, I have Zulu time to Tokyo time. So if I store in Zulu here and someone in Tokyo, they want to get that data back, is basically just switching to their time zone. So usually applications, they will always work with UTC, and when the user or the developer, they are fetching the data back, they change the data to the time zone that they are in. So a little bit more about the instant. You can get the epoch second. So for example, you can get instant.epoch second. And as I said, you have two variables, one to hold the seconds and another one to hold the nanoseconds. So the nanoseconds, it will be a value representing the last second of your nanosecond. Sorry, the last second of your epoch second. The maximum value for this nanosecond will be 900, 999, almost 1 billion. So when you reach 1 billion nanoseconds, it will flip 1 second. So 1 second of this epoch second, this 7, this is the nanosecond. When this reaches like 1 billion, it will flip this to 8. We can play a little bit. For example, south instant. Actually, let's get a new instance of epoch second. So let's say 3. This will add 3 seconds from January 1st, 1970. And this is the Zulu time zone. And if I have something passed into the nano adjustment, for example, I can say 1 billion. You will see that now this will be 4. If I don't send anything, it will be the same 3 seconds. And if I send something like, let me copy this one, let's say that I will send a 9 here. Shift F10, almost flipping to 4 seconds. And you can also send negative. So from 3 seconds, if I want to have 2 seconds, I can adjust this negatively, passing minus 1 billion, and I have 2 seconds. So when should you use instant and when should you use, for example, local date time? So local date time, as you saw, is a class that was basically created for humans. We can add plus days, we can add plus weeks, we can get year, and instant, they don't have that many methods for us. So we have a plus seconds, plus nanoseconds, plus milliseconds. So basically, it's more like computer to computer communication, or when you are logging information that basically does not need to be read by humans. Of course, it's still understandable by humans, but let's say we don't have to manipulate that data like in a report or anything that fancy. So this is another class inside of the package Java Time. I hope you enjoyed. Let's continue because we have many more classes to talk about. See you in the next video. Bye.